Let's look at another linear inequality in one variable that contains fractions. Just as we do with linear equations, in fact, just as we do with basically any equation, when we want to get rid of the fractions, we multiply both sides by the least common denominator. And here the least common denominator is 4. So I'm going to multiply each of these terms when I distribute the multiplication. I'm going to multiply each of these terms by 4. I'm just putting that number up there to indicate I have to distribute that multiplication of 4 times both of those terms there. It's kind of my think cloud. That's kind of what I'm thinking. Well, here, the 2 can go into the 4 2 times. That gives me 2x. Minus, the 4's cancel. That gives me 3. The 4's cancel here. That gives me 7x. Minus 4 times 2 is 8. The fractions are gone. My linear inequality in one variable is much less complicated. I can now finish out the solution. Let's subtract 2x from both sides. So negative 5 is greater than 5x minus 8. Let's add 8 to both sides. 5 is greater than 5x. And now I'll divide both sides by 5. So 1 is greater than x. So we want all of the x's so that 1 is greater than x. Well, isn't that the same as saying that you want all the x's so that they are less than 1? If I want all the numbers that 1 is greater than that number, I'm talking about numbers like 1/2, 0, -1, -2 3/4. Aren't all those numbers where 1 is greater than those numbers? And aren't those the same numbers that are less than 1? So those are equivalent statements that we can write with that inequality. And that's the solution set for our original inequality in one variable.